So what we did was there, we looked at the quality of a gas in terms of flowing, correct? So gases flow. So if the environment, if the atmosphere is made of a gas, it's gonna literally, you ready for the word? You ready? It's gonna settle. But it's not going to settle completely. It's going to kind of make a puddle, where maybe the middle of the puddle is thicker than the ends of the puddle or something. I don't know. You get it? Okay. This was what we did. HCl plus sodium bicarbonate. HCO3 is -1 charge, +1 charge, NaHCO3, no big deal. You form carbonic acid and carbonic, no prefix, it's a ternary acid. 8 becomes ic, carbonate, carbonic, plus NaCl. You form these two molecular compounds from this, you get water and CO2, correct? That's actually driving the reaction. This really isn't taking part in the reaction, is it? Not really. Not really. It's an ion over here. Ion. These are aqueous. This isn't gaseous. Aqueous, aqueous, aqueous. This is really what is driving the reaction, correct? Yes or no? You get it? Okay. So I just wanted to look at flow of the gas. Yeah? Now, many years, I'm going to get rid of this picture. Yes? It says low battery? Okay, I'll take care of that in a moment. Okay, let me just erase all this. Remember we said, I've got to get my computer and hook up that, okay? So if I'm going to leave the screen for a second. Let me raise my voice, okay? Many years ago, could someone look up, I need 3 volunteers, quickly. 1, who else? Come on. Who has a computer? Extra credit. Kennedy, thank you. Eamon. Good. You ready? Look up death of village in Africa near volcano. Put that in your search. Death of village in Africa near volcano. That's all you have to put, okay? All right, now. All right, so that's low battery, so I'm going to hook up my handy-dandy computer. And I'm going to put this in like this. See some shaking. Dismiss the battery. And we have what we need. Okay, good. Now, did anybody come across what it is? What did you find? Death in Africa of an entire village because of a volcano. What did you get? And it wasn't lava that killed anybody. It wasn't heat that killed everybody. What was it? Anybody? Yes, go ahead, Aiden. Not ash. No, it wasn't ash.
Gas.
What gas?
Acid gas.
No, not an acid gas. Go ahead.
Sulfur gas.
Sulfur dioxide, carbon dioxide.
Sulfur dioxide.
No, so it was the gases that actually can form acid rain that are given off by volcanoes and sometimes burning coal. Sulfur dioxide, carbon dioxide. Yes, we have a visitor, Professor Brown. Yes, the true leader of the entire building, and I hope Dr. Miner is listening, okay? Yes?
Can I speak to Laura, please?
Laura.
Vares.
Laura, front and center. Thank you. Okay, now, so you have a volcano. Here is this is just a very rough. This is a very rough drawing of the area. Okay. Okay, I'm going to erase this. Okay. You ready? Very rough. Okay. So you have this kind of You have these houses here. Here's the ground. Right, there's the dome, right? This is a giant lake. Right? Giant lake, right? Very deep. And what happened was it literally belched. At the bottom of the lake was this gas that was trapped by the enormous pressure of the water on top. And we talked about on a tape yesterday about that I did a film for section 3, your section 2, right? Where we looked at pressure is not a function of how much water is above you. It's a function of the height of the column that's above you. In other words, if I'm at the bottom of a bathtub that's 1 mile deep, it's the same pressure as if I'm in the Atlantic Ocean 1 mile deep. Same pressure. Or Lake Baikal, which is a narrow lake in southern Siberia, not far from the Mongolian border and the capital Ulaanbaatar. So it's based on depth. So this is very deep. Yes? Clear? It belched these gases one night. Everyone was sleeping. Well, what happens is it comes out here. These are heavy. Carbon dioxide, 44. Air, 29. Remember that? Carbon dioxide, 44. What's sulfur dioxide? What's the molecular weight of molar weight of sulfur dioxide? What is it? The molar mass? 32, 16 and 16 is what? 64. So very heavy, aren't they? Very heavy. So they literally covered the village in a sea of gases. Everyone died for lack of oxygen. It just displaced the air. The air is up here. This is the poison gas. Clear? So we've well established now that gases like the atmosphere can flow, can settle, they have weight. They are affected by gravity. The pressure is dependent on the height of the atmosphere, right? Correct? Isn't it? Just like I am not subject to the entire atmosphere on Earth, am I? I'm just subject to the material above me, the height of the column. Do you get it? You don't have to worry about the volume of the material above you, just the height of it. And I did that yesterday. It's a very important video to watch. Okay, now. I asked you to look up some vapor pressures at 40 degrees, 60 degrees Celsius. And they were, what were they? What were they? What were the gases? What were they? Ethanol. Is that right? Ethanol, drinking alcohol, right? Yes? What else? Chloroform. Okay, what else? What is it? Water. And what else? Use the common name. It's right in the book as ethanoic acid, but it's really acetic acid. Right? Yes? Okay. And I wanted you to look up very informal looking chart, would you say? All right, so what was, at 40 degrees, what's the pressure of ethanol? Come on, guys, you looked it up and you wrote it down, right? Remember I asked you to do that? So what is it? I need somebody to answer the question. I know this isn't a verbal class. T, can you help me out? Do you have a book?
Yeah.
Can you look it up? What page?
429.
429? The class is stunned by this material. They're simply losing the ability to think because they're so overwhelmed by the phenomenon. Yes, I'm sorry? 20? This is kilopascals, right? Kilopascals? Is that what it says on the y-axis? Yes? Okay, so it's kilopascals. Okay, so this is going to be what? The vapor pressure? Yes? This, and it's going to be in kilopascals. And this is going to be the vapor pressure in kilopascals at 40 degrees and 60 degrees. And what is it for ethanol at 40 degrees? Do all four at 40 degrees. What do we got? Just round it. It's okay. Round it to ones place. What do you got? Ethanol is 20? 50?
No, ethanol is 20.
All right. Ethanol is 20. Okay. What's chloroform? 50. Excellent. What's water?
8 or 10.
What is it?
10.
10. Now these are rounded values. You'll probably find other ones. This is read off a very simple graph. And what about acetic acid?
5.
5. And what about 60 degrees?
Ethanol's 50.
What is it?
50.
50. And what about chloroform?
100.
100. What about water? What is it?
24.
21.
I just need a number, guys. 22? Okay, good. And what about acetic acid?
50.
50? Okay, good.
No, 15. 15.
15, 1, 5, okay. All right, you got it? You with me? Yes? So, you've heard the word, has anybody ever heard the word volatile? Maybe with behavior, he's very volatile. What does it mean for a liquid to be volatile? What does that mean?
To evaporate easily.
To what?
Evaporate easily.
I can't hear you.
To evaporate easily.
To evaporate easily. Yeah, that's actually quite true. If something is very volatile and evaporates easily, would you say that relative to water, let's use water as the standard, would you say if something is more volatile than water, if something evaporates more easily than water, would you say that the vapor pressure at the same temperature would be higher or lower for a volatile liquid relative to water? Higher, much higher. Look at this. Is chloroform at 40 degrees more volatile or less volatile than water? More volatile. Is ethanol more or less volatile than water? Is acetic acid, vinegar? Vinegar is the operating ingredient in vinegar. Acetic acid is the operating in vinegar, is the operating chemical in vinegar, yes? More or less volatile? Less. What about at 60 degrees? Same? Okay, good. Now, I'm going to erase that, okay? And I'm going to stop the tape. We've got 8 minutes. We're going to do this, okay? I want you to tell me, for these 4 chemicals, at what temperature are those 4 chemicals equal to the atmospheric pressure at sea level? And what does that mean? Okay? Do it right now.